So as I had said, I have downloaded the Facebook data. See, the edge list format, as I had explained, has been used here. There is an edge between person 0 and person 1, person 0 and person 2, and so on. See, the persons have been anonymized, that is, you don't know the name and other details about the person. They have been associated some dummy ID, and that ID is used to identify the persons. That is the way you identify the nodes in the network. So it's an anonymized data that you can download from the link that I had shown in the PowerPoint, and it would be available in the description as well. You can check out that and you can download this data. Now, given that we have seen our data, let us get to programming. Alright, to deal with graphs, we have a package in Python called NetworkX. Let me import it. Import NetworkX. And given that the name is lengthier, let me use a shorter alias name by as NX. I'll call it NX. So this is how the package that you use to analyze the graphs. So as I had shown, the data was in edge list format, so I had to read that data. So for that, the functionality is NX dot read underscore edge list. See, the names are also intuitive. You can understand what it does, and see, you are getting the arguments. You have to give the path of the file. In my case, the file is in the same path as that of my program, so I am just giving the name of the file. If you are having the file in different path, you need to specify the complete path. So the name of the file is Facebook underscore combined dot txt. That is the name of the file. Alright, maybe I'll maximize this pen so that it's easier for you. So I have maximized this pen. So you have read the edge list. So as a result of reading the edge list, a graph object would be created. That is, a sort of graph structure would be created, and we need to capture the created structure. So we'll capture it by the variable g. G for graph basically. So we'll capture it this way. Alright. So what I'm going to do is, I'm going to compare the shortest path length. By length, I mean the number of edges you have to pass if you take the shortest path. That is, in our example, from Chennai to Kolkata and Kolkata to Guwahati was the shortest path. That is, there we had passed two edges, Chennai to Kolkata and Kolkata to Guwahati. So that 2 is the length of the shortest path, is what I say. So like that, I'm going to find the length of each pair of nodes, shortest path. That is, the shortest path of each pair of nodes is what I'm going to find. So for that, I need to take the list of all the nodes, right? So let me capture that in a variable n for nodes basically. Let me say is equal to list of the nodes is what I want. So let me typecast it to list, and I will obtain the nodes of the graph by telling g dot nodes. This is how you get the nodes of the graph, and you are converting into a list format. So you are getting the list of the nodes. So that is what you are doing. As well as the intention that I am having here is, I am going to find the length of the shortest path between each pair of nodes. Each pair of nodes possible. So between node number 0 and 1, 0 and 2, 0 and 3, 1 and 2, 1 and 3, 1 and 4, and so on. So on. Each pair of nodes possible, I am going to find the length of the shortest path. And I am going to observe something. So let me do that. For that, I need to store the length of the shortest path in some list to observe something. So let me store it. Let me say shortest path list. Shortest path length list. So shortest path length list, let me say. I need a list. I'm having an empty list here. And now, as I said, I'm going to check for each pair of nodes. right? So I need to run a loop and iterate over all these possible nodes. So I'll run a loop for u is a node, let us say u in nodes. We have captured the list of nodes in the variable n, u in n, as well as we need pairs, right? This u would capture one of the node. We need to capture another node so that we find the length of the shortest path between that pair. So we'll find we'll take another node for v in n. So what I am going to do is I'm going to find the length of the shortest path, but it should not be found for all the nodes, because if both the nodes are the same, then it doesn't make sense, right? I want to go from Kolkata to Kolkata. It doesn't make sense, right? So these two nodes must be different. So only if they are different, you should go for finding the shortest path length. So I'm going to give the check here. U is not equal to v. That is, the nodes are different. In that case, you have to find the length of the shortest path. Let me call it L for length. So for that, we have a functionality in NetworkX, nx dot shortest path length. See, you have a functionality here, shortest path length, g source target. This is the format. So you have to pass the graph object g, and your source node is u, target node is v. Between these two nodes, you want to find the length of the shortest path, and let us print it. Print, let us say, shortest path between u and v is of length L. We have captured the length in the variable L, so we'll display that L here. As well as I had said, I'm going to append each of the shortest paths calculated onto this particular list, shortest path length list. So I'll append that, shortest path length list dot append the value of the value of L. So till now, what I have done, I have read the edge list format graph data, and I have captured it into a graph object. First, I had imported the NetworkX library. Then I had used it to read the edge list format data, and I have imported into a graph object. Then I captured the list of all the nodes from the edge list, that is the edges were given. From that, we have to capture the list of all the nodes that we had done, and we are planning to find the shortest path length between all possible pair of nodes and do some analysis on it. So that is our aim. So for that, we'll have a list, shortest path length list, which will store the list of all the shortest path lengths, all possible pairs shortest path length. They will be stored here, and so we need to find the length of all possible pair shortest path. So for that we are iterating over the list of nodes. We take a node u, we take another node v. If they both are different, we go for computing the shortest path length, and we print the length of the shortest path. Then we append it to our list. So by the end of this loop, all pair shortest path is calculated, and you have that stored in this particular list. So now from this, I want to find the minimum value, that is the least value of the shortest path between the two pair of nodes. So that I can say, I can say the minimum value of the shortest path. Let me say minimum shortest path length is nothing but, I want to find the minimum value from this list. This list will contain the lengths of all pairs shortest path. So I want to find the minimum value. So let me find the minimum shortest path length list. So from this list, I want to find the minimum value. Just like minimum, I want to find the maximum. Let me copy and paste it and modify. I'll copy, I'll paste this, I'll say maximum. So for this I need to use the functionality max. So min is a functionality that will return the minimum element in a list, and max is a functionality that will return the maximum element in the list. So maximum of all the shortest path length would be returned here, and the minimum value would be returned here. So given that we have found the minimum and maximum, what next mathematically? Average, right? We want to find the average shortest path length. So to find the average, we need a package called NumPy. Let us import it. Import NumPy. This particular package has most of the mathematical operators that we generally use. Average operator is also defined in this particular package. So I have imported NumPy, and let me find the average. So average shortest path length is nothing but, in NumPy package you have average function. See, you could get it here, average, and from this list, shortest path length list, from this list you want to find the average. Alright, so you have found it. Now the next job is you want to print all these values. So let us print minimum shortest path length. Okay. That is stored in the variable minimum shortest path length. Right. Just like this, we want to print the maximum as well as average, that whatever we have computed, we want to print the values. So let me copy and paste here, and let me make the modification. Minimum and maximum. The next we want is maximum, and that particular thing is stored in the variable max SPL. So we'll have it here, and the next thing is we want to find the average. Average shortest path length. Average shortest path length. Alright. So we are done with our program. So maybe I'll save it, and we'll have a quick overview. To analyze the graph data set, we need NetworkX package. We have imported it, and see, we are reading it from the edge list format that we have downloaded. We read the edge list format, and we captured the graph object, and from that graph we are extracting the list of all the nodes, and then we want to find the shortest path length between each possible pair of nodes in the graph. So that is our intention. For that, to store all the lengths and analyze later, we are having a list which stores all possible shortest paths length. So to find the shortest path length between all possible pair of the nodes, we have loops, two for loops running. You pick a node U, you pick another node V, and if they are different, you find the shortest path, print it, and append it to the list. That is what you are doing. So at the end of this loops, what happens is, between every possible pair of nodes, whatever is the length of the shortest path, it would be stored in this particular list. So now we are analyzing this list. We are finding the minimum of all possible values, that is all the values of all shortest path length. We are finding the minimum, then maximum, then the average. To find average, we need a library called NumPy. So we have imported NumPy. In NumPy, the functionality of average has been defined, and we are importing it. So given that we have computed all these values, we will be printing it. That is what we are doing. And by 6 degrees of separation, what we mean is the average shortest path length. On an average, you can reach from anyone to anyone on the earth if you take the shortest path by maximum 6 hops, that is the average shortest path length would be maximum 6, is what we mean by 6 degrees of separations. So let me give you an intuition for why this is true. So just assume that you have 100 friends in your Facebook. So we generally tend to make friends with people who are like us, right? So those friends may also have further 100 friends. So at the next level, if you consider your friends, that is 100 into 100. At the next level, it is 100 into 100 into 100. See, if you go just one level below, the number of people you met is increasing exponentially. So if you just trace 6 levels, you can definitely cover the entire population of the world. This is the intuition behind 6 degrees of separation concept. Okay, I hope you are clear with the concept, you are clear with the terminologies of graph data structure, how to deal with it, how to code it. I hope you are clear with it. Maybe you can pause here, think for a while, and you can then proceed with running the code. And this is not just the only functionality that is available here. Actually, there are a lot of functionalities available here. Maybe let me show you. NX dot. I'll just press a tab. NX dot. NX. I'll show you the other functionalities. NX dot. See, a lot of functionalities are available here, and you can go to the console, and as you know, by typing in the functionality and giving a question mark at the end, you would get the documentation of what that functionality is all about. If you have some idea of graph theory, the math behind it, if you have some idea, you can understand it really well. But still, even if you don't have it, it's never a problem. All this is nothing but the intuitive things translated into hardcore mathematics. That's it. It's really very easy. You can pick up that. So I would recommend that you guys explore this NetworkX library really well. You understand the various functionalities. You see that what all can be done. You'll realize that it has whole lot of things which is otherwise difficult if this is not present. If you are asked to do this all paths shortest path, to find the shortest path, there is an algorithm that runs for the mathematics behind it, everything. It runs for some pages in some standard textbooks, if you see. So we have this particular functionality that finds the shortest paths. That makes our life easier. If we were to implement this from the scratch, it would take a lot of time. So NetworkX really simplifies our tasks of dealing with graphs. So you can analyze the parameters of the graph without having to worry about the minute details. That is the advantage of using NetworkX. Right? Please do explore it. Okay, let me save and run it. So before that, let me restore the pane. Alright, so here we have the output. We'll be getting the output in the console. So let me run the file. See, the shortest path is being computed between the different pair of nodes. Are you getting somewhere more than 6? The average would converge to 6. It would take a lot of time because see, there are so many nodes. See, 3,900. Some nodes are there. So there are around 4,000 nodes, I guess. You can check out that in the description of the dataset as well. How many nodes and how many edges are present is given there. Given that there are so many nodes present, it would take some time to compute, but you can see what is the minimum, maximum, average. Also do explore the other parameters, and please do discuss in the discussion forum of your explorations. Thanks for watching this video. Have a nice day.